Good evening, Nano fam. Welcome back. Hello, everyone. Please say hello in chat so that I can put you on the spinner wheel. And as you can hear, I'm still a bit cold. My voice is still a bit, bad, but it's okay. I'm feeling much better. Hey, Sergio. Good afternoon. Good afternoon. So yeah, hope you guys are all good. Had a good week. Butterfly, hi, good evening. So if you want to take part in the giveaway, just post your nano address in chat, and I put you on the spinner wheel. So let me just do that right now. Get well soon, says Butterfly. Thanks. Yeah, I'm much better already. And let's start the Bitcoin timer. So in 10 minutes, we give away the first nano. I think I have not read your name before, Butterfly. Are you new to the stream? Oh, great, a nano address. So we have on the spinner wheel Sergio and Butterfly. So just 2 entries right now. So that means you guys have really good chances. So let me add you to the address book. Yeah, so how was your week? Let me know. Anything happened? I was a bit busy with working with Gravity. We wrote a little tool that helped us analyzing the network traffic between nanonodes. Butterfly says, yes, new. Hey, that's cool. New guys in the chat, that's cool. 1401, keep your wallet where the wallet belongs. Butterfly, let me add your address quickly. All right. And 1401. Hey, 1401, do you want to send your nano address? Then I can put you on the wheel too. Yeah, so I worked a bit with Gravity, and we wrote a small tool, and it is on GitHub, and it is very hacky, and it doesn't work in all cases, but it is good enough. It is good enough for our use case where we want to analyze network traffic between nanonodes, and you can find it on his GitHub. So this is Gravity's GitHub here. And it is, where is it? Nano PCAP server. So this little tool, it takes a PCAP, a packet capture file from TCP dump, for example, and it converts the PCAP file into a JSON file with all of the nano messages, and it does this by reusing our RsNano Rust code. So that's what I did last week. So this is the PCAP parser tool. So if we have a look at the cargo toml, which has all the dependencies, you can see that it uses RsNano core and RsNano messages, and that is new. I created the RsNano messages crate last week, and it contains all of the message code, all of the messages that go from node to node. So if you want to build something with the nano messages, you can use the RsNano crate for that. Isn't that cool? Butterfly says, it was better than the previous week for me. That's a progress. And 1401 says, yeah, it's just watching for now. Okay, that's fine. Yeah, so that was cool because it just shows that the stuff we built here on RsNano has other use cases, and we could just very quickly reuse the Rust code, and it would not have been that easy with C++ code base. So yeah, I think we will have more tools like this here in the future. And Oh, it's a bit small, huh? Let's increase the font size. And yeah, so then I spent some more time with what we did in the last stream. So in the last stream, I stumbled upon the wallets class. Sorry, the wallets class. And said that we have to bring parts of it to Rust before we can go on with porting the vote generator. And this turns out to be a monster. So wallets is a big class, and it has dependencies to wallet. And wallet has dependencies back to wallets. So it's a circular dependency here. And that does not work well with Rust. So yeah. So I started to yeah, I did not really know where to start. So in the last stream, I just drew this diagram here, and just to get an idea of with all of the dependencies. And then off stream, I began with the following idea, and I want to sketch this idea quickly. So let's create a new diagram here. So, and let's add again we have the wallets class. So wallets is a container of all wallets that a node has. So a node can have multiple wallets. And a wallet is defined by its seed, and it can have multiple addresses. So it is LFLF is here. Hey, good evening. So LFLF, you go on the wheel too. Just in time, because the next big Bitcoin block is 3 minutes away. Yeah, so wallets uses wallet, and wallet has back references to wallets. And then each wallet has a wallet store for storing the I think the seed or the seed and the addresses. And so these three classes are really, really big, and we can't bring them to Rust with this circular dependency. And it's not just, that's what I found out in the last stream, it's not just one or two places where there's a back reference. There are actually a lot of places with a back reference from wallets to wallets, as you can see in this other diagram. So let me just switch back to no, that's not it. That one. So as you can see, all of these blue lines here are back references, and there were even more because I removed a couple of them already. So there were even more of them. So that reminded me of a principle or an approach that we could take here. And the approach goes like this. And I want to talk a little bit about cohesion and coupling. So these two terms are very, very important in software engineering. So what we have here is we have coupling. We have wallets is coupled to wallet, and wallet is coupled back to wallets. And if we have a lot of those back and forth, that sends a clear message to us as developers. And it says that this separation of wallet and wallets is not a good idea, because if there are so many references back and forth, it just means that it should be together. It should not be apart. It should not be separated. So that's what I started then. What I did is, no, I have not even started that. what I did is there's a lot of other code, like in the unit test, for example. So the tests. So this box, I just say tests. So this represents the tests. So the tests, they work with the wallets class. Sometimes they work directly with the wallet, and sometimes they work directly with the wallet store. And that was my starting point. So what I wanted to do is I wanted to only use the wallets class, and I want to hide information hiding. I wanted to hide these two beasts here. So I wanted to not have this dependency. I wanted to not have that dependency. Oh, and also that, like the node, the remaining node code too. So there's also the remaining node code, which also had usages of wallets and of wallet and of wallet store, I think. Yeah, and yeah, let's give away the first nano. Is everyone on the wheel? LF, Sergio, and Butterfly. Anyone? Do we have more people who wanted to participate? Sergio and Butterfly and LF. Okay. Then let's go. LF says computer science lectures from Gustav makes sense to separate, but could you not use arc mutexes for these back references? Yes. LF, congratulations. The thing is, yeah, we could use arc back references, but it is very unidiomatic. Rust idiomatic to use a lot of arcs, and with arcs we would have to use weak pointers for back references. Otherwise, we would have otherwise the instances would never be destroyed. So if we have two arcs referencing each other, those instances would never be destroyed, because those arcs would always have at least one life count, So that's tricky. So, and also it makes object construction difficult. Fortino1 asked, what's the tool site you're using for diagrams? It's called gschauwecker. And they have a free version and a paid version. And I used the free version for a while, and I liked it so much that I got the paid version. But the paid version is the same, actually. It just allows me to have multiple diagrams and to synchronize them over multiple PCs. Yeah, I like it really much. So, yeah, so this is what I wanted to do first. So I wanted to get rid of all of the direct references to wallet and wallet store. So let me just delete those. And just to use the wallets as a gateway. And the reason why I did that is because if we hide the wallet store and the wallets, we can massively change them. And we have to massively change them to bring them to Rust. So this was the first step, and I'm not completely done with it. So I think I changed most or all of the tests. We will have a look soon. I think I changed most of the tests that they just use the wallets class. And I think I have not changed the node yet. And so the idea is then to, after all the tests and the node only work with the wallets class, then I can go into the wallet class and move all of the code that does back references back into the wallets. So then wallets will get really slim, like really small. Let's make it really small. Or maybe it will even be deleted. I don't even know yet. So then this wallet will be very, very small. And there will be no back references. And then we can bring it to Rust. And then we can maybe split the big wallets class up into smaller parts again. So this is an approach that I've did a lot, and I think it's very valuable. So if you have a mess like this one, bring the code together. So the diagram, it shows clearly that the way wallets and wallet are separated is not a good way. So we have to separate them in a different way, in a better way. So let's bring all of that code in together into one class, into one function. Just create a huge blob, like the thing that we just don't want to do on a normal day. It's okay to do it here. So bring the code all into one place so that you can have a look at it, and then we can split it up again in a better way. So let's see how far we can go today. So first thing I want to do is I want to check if there's any more tests or node code that uses the wallet or wallet store class directly, and then I want to change that sorry, to use the wallets class. And when we are done with, oh, I did not restart the block, the Bitcoin block timer. And then when we're done with that, then I want to move all of the back-referencing wallet code into the wallets class. Okay, Nano fam, are you with me? Any feedback on this? Okay, then let's have a look. And oh yeah, maybe I should also explain. Maybe I should have started with that. So yeah, what is this wallet and wallets and wallet store? So a node can have wallets, and we need the wallets when our node should send or receive nanos, or when we want to make our node a principal representative or just a representative. So for voting, we need a wallet, because the node will sign its votes with the wallet keys. So that's why the node has a wallets class. And there can be many wallets inside a node. There can even be many representatives inside a single node. So that's why we have the structure. That's why we have the wallets class. LFLF says, sounds logical. Thanks for the explanation. Yes. Okay. So let's have a look at the wallets class. So all of that code is in wallet.hpp and wallet.cpp. And here we have the wallet store. So this is in Rust already. This is an interface for the database, because we have to save the seed and whatnot. And LFLF says, how are you doing health-wise, by the way? You still sound sick. Yeah, I'm still a bit sick, but I feel much better. Much better. You know, if you have little children, they bring home all kinds of you know, all kinds of viruses or whatever. And I'm just, I get them too. My girlfriend doesn't, but I do. Yeah, so then we have the wallets class. So this is the huge gateway thing, and have a look at that. So many functions there. Lot of responsibilities. And this even got bigger now because of my test refactorings, where I had to add a lot of functions here so that the tests would just interface with this class only. But there is still, let's see, for example, this function get wallets, which returns pointers to the wallets. I think this cannot be here anymore. And there's also a public field. So I wanted to start with the public field. This here, it is called items. And what items is basically the wallets. This is the unordered map of wallet ID to wallet. And this is public. And we want to hide the wallet map here. So let's start here and let's search for all references to this public field. And we have quite, we have some. Oh, by the way, do the chat notifications work? I have not checked. Did you guys see pop-ups when you wrote a chat message here on stream? Oh yeah, we will find out. Well, let me just try this test message test. Yeah, okay, it works. Okay, so there is LFF tests test 2. Okay. So as you can see here, all of these references are in the wallet.cpp file, and that's okay because that is internal. So we don't have to worry about these references, but we have to worry about the JSON handler out on the top. 1401 says, does wallet store private keys once generated, or does it generate the private keys from seeds dynamically and delete them afterwards so only the seed is stored? Oh, that is a really good question. And I don't know the answer. Let's find out. That's a good question. Let's find out. Does it generate the private keys on the fly? Or does it... let's see. We have the wallet store. This is the wallet store class. And here we can load and set the seed. And I think this here, deterministic insert, I think this creates a new private public key pair. Or doesn't it? Let's have a look. What does deterministic insert do? Okay, so this goes now into our Rust code base. So let's switch to the Rust to the Rust code base. So this is wallet store deterministic insert. Here we are. So what does deterministic insert do? Oh. Index, private key. Deterministic index, deterministic key. So, not so sure. What do you mean? What do you think, chat? LFLS says, what about system CPP in the bottom? Yeah, so the system CPP in the bottom is also a problem. We have to fix that too. So, but just to answer 1401's question, are those keys created on the fly? Or are they... So here, the deterministic key function creates the key pair. The raw key, yeah. So it takes the seed, and then it uses the seed and it takes an index. So because we can just create a lot of private keys from a single seed. So index is the number of the private key we want to generate. So this creates the private key, deterministic key. So this is cool now. We can learn together, chat. We can learn about Nano. Because this code is also new for me. I have not worked with it a lot. Deterministic insert. Insert, here we are. So what does it do? So it creates here we create the private key from the seed. And I think the first one, the deterministic index get, just gets the next index, so the next key to generate. And then we create the private key. And what does it do here with entry put raw? What is marker? Do you have an idea, chat, what this code does? Marker. Yeah, it looks to me that this just updates the index in the database, and it does not. It looks to me that this does not store the private key. It does not look like that. So my guess is that it creates the keys on the fly. What is this? Move keys. Oh no, okay, here we have something. Alright guys, 1 nano for, oh, is it Butterfly or is it Sergio? Oh, that was close. Sergio, 1 nano for you. Come on guys, send your nano address. Then you can take part in the giveaway. So this here, insert ad hoc. So this here stores a private key. It encrypts the private key with the password of the wallet. And then it... Bob, oh, you missed the... Yeah. Oh, okay. So let's just put you on the wheel so that you are on the wheel for the next spin. Yeah, so insert ad hoc stores private keys. And fetch loads a private key, given the public key. So yeah, so they are stored. Insert ad hoc. So let's go back to the C++ code base. And let's find out where insert ad hoc is called. In the wallet class. In the wallets class. Yeah, okay, so 1401, the keys are stored. The keys are stored in the database, but they are stored encrypted with the wallet password. All right, yeah, back to our references. So JSON handler still uses the items field of our wallets class, and it does it. So what does it do here? It loads the wallet. And then it calls wallet locked impl and a wallet account impl. And then it also does a direct access to the wallet store. So we have to fix all of these places. We have to fix all of them. All right. Wallet locked impl. What is that? So the JSON handler, by the way, is, so this file is for the RPC, the JSON RPC interface that we can call for when we have it enabled for the node. And this code here belongs to the function block create. So there is a block create call that you can issue via HTTP, and then it would create a block, and this does whatever it does. I don't know what it does here. We don't even have to know what it does here, but what we have to do is we have to fix these couple of lines so that they don't work directly with a wallet and that they don't work directly with the wallet store. And so let's find out. Let's find out what wallet locked impl does. Wallet locked impl, here we are. So it says store. So this also goes to the wallet store directly. So it checks the password. If the password is valid. Okay, so this is a helper function and its only responsibility is to set the error code. So if the wallet password was not entered, it will fail with the error code wallet locked. And this error code is in the response. Yeah, so we don't want our wallet locked impl to work with wallets. We want it to work with the wallets class, so plural with an S. So maybe let's go back. Maybe we can change this just a little bit. So wallet is the wallet ID. That's also confusing. So this is the wallet ID. And instead of loading the wallet here with items find, we could just what could we do? So I don't want to pass the wallet here, but I want to pass the wallets and the wallet ID. Like that. The wallets and the wallet ID. So let's add that here. So we want to add the wallets, so nano wallets, and the wallet ID. And these two I have to also add in the header file. What is that? Wallet locked impl. Yep. Okay. And do we have multiple places that? Yeah, okay, we have to, oh, now we have to adjust all of them. Oh no. But I want to just finish this. Yeah, so let's just finish this one. So instead of going to the store of the wallet and having valid password, I want to say wallets A, and I think I already have a valid password function there because I had to put one for the tests, and this takes the wallet ID and the transaction. So as you saw, this was just a very small change, but with this small change we can now delete the wallet pointer because we don't use the wallet pointer anymore. So let's do that. Let's delete the wallet pointer. And now we have to find all places in the code that called wallet locked impl and use the new signature. And the new signature is, so here we are. So account remove did the same. So account remove, we have to say instead of wallet. No, what is wallet? Yeah, this is okay. This is actually the wallet pointer. So here we have to say, oh, okay. This is also tricky. Wallet is the wallet pointer because this calls wallet impl, and wallet impl already returns wallet open. Wallet impl. We have to change this too. Are there many references to wallet impl? Oh yeah, there are. Oh my god. Okay. We should have started with this function. Let's create an alternative implementation. Let's create a wallet ID impl. Or maybe I have done that already. No, I don't. Yeah, let's copy this code. I want to duplicate. So duplication is okay as long as it is short-lived. And this duplication is short-lived. Duplication is not okay if it is long-lived. So wallet ID impl. So what I want to do is I don't want to return a wallet. I just want to return a wallet ID. So this, because this is a helper function, it extracts the wallet from the HTTP request. So in the HTTP request, there is this wallet ID string, and it decodes this string, and then it loads the corresponding wallet. And I just don't want to return a wallet. I just want to return the wallet ID. Okay, let's spin the wheel. Hey, Butterfly, congratulations to your first win. Butterfly, 1 nano for you, and there you go. Yeah, so this is a helper function, and we just create a copy now, and our copy does not return a wallet. It just returns a wallet ID. So nano wallet ID. And yeah, so it does not return existing. So it just returns wallet, because that is the wallet ID. This is really confusing. That wallet is wallet is a wallet ID. Yeah, okay, so what should we return in the not found case? Does it even matter? Because I think we check the error code always. So whenever we call wallet impl, afterwards we check the error code. And the error code will be either wallet not found or bad wallet number. So I think it does not really matter what we return. So maybe we can just return that. Like the default. I think this is okay. So let's copy this and add it to the header file. Oh, what is this? Get wallet ID? I knew I did it already. Chat, here we have the function. I thought, man, this looked so familiar. I had the gut feeling that I had done this already. Okay. So let's delete that code. We have it already. It's just a different name. It's called Get Wallet ID. All right. LF says doppelt hält besser. Yeah, that's German. And it's a German saying. In German, we say doppelt hält besser, and that means if you a double. Oh, how do you translate that? If you do it twice, it's better. Okay, so we can just reuse that thing we have already. How do I find where we were? So wallet impl. account remove. So this was the function we wanted to fix. So instead of wallet, we say wallet ID, and we say get wallet ID. And then down there, where we say wallet locked impl, we have to give the wallets. How do we get the wallets? How do we get the wallets? What is RPCL? A JSON handler. Node wallets. And the wallet ID is the wallet ID. Okay. And the same problem in the wallet account impl. How many? Wallet account impl. Wallet account impl. Is this also being used in so many places? No, this is just a handful of places. Okay. Then usually I work in small steps, chat, but I think not this time. So in small steps, we could do it in small steps. In small steps, we would create copies of these functions. One copy would work with wallet ID and wallets, and the other would work the old way, and then we could just, in very small steps, switch from the old functions to the new functions. But today I'm adventurous, and I'm gonna do it in one big step. Fortuna1 says that whole section is a wallet Matryoshka doll. Yes. So the wallet code currently in its current form, the whole wallet code is not as good as it could be. But we are going to fix that. But not today. Our first goal is to bring this to Rust. And then we can clean it up. Okay, so account impl. Yeah, I'm just gonna do it in one big step. And the big step is so it will not take a wallet, but it will take a nano wallets reference and a wallet ID. So let's copy that and fix the header. So okay. And that means, what does it do? Oh, this also does an access to the wallet store find account. Okay, it just checks if this account exists. And I think I want to do this in an inefficient way, but this way we will be done faster. And maybe I'm going to add to do. And the inefficient way is we say wallets. Get accounts. So we load the accounts for the wallet. And then we... Wait a second. Oh, what about the transaction? This doesn't take a database transaction. It uses its own transaction. Oh, we are... Okay, maybe this one big step is backfiring now. Maybe I shouldn't have done it in one big step. Transaction. This. Okay, I just want to see what's up with these transactions. Okay, here's. Oh, do you know the term yak shaving, Chad? Have you heard that before? When you jump from one task to another task to another task to another task just to get the original goal done? I think this is the yak shaving session. So, wallet account import. Let's go back. So the transaction is a problem because the transaction is open already. So we can't use this get accounts. We have to use one with an existing transaction. And this will load all the accounts. And this is inefficient because it just loads all accounts and then it copies them. So let's add a to-do here. Don't load all accounts. And we fix that later. LFLF says, do you also participate in Advent of Code, by the way? Not this year. So I did last year and the year before. And this year I opened the first day, the first star. But I decided to stop there because I just don't have much time. Not much free time. And these puzzles, they're so much fun. I really love them. And they start simple and then they get harder and harder. And then they take a significant amount of my time. So I don't want to spend the time on the Advent of Code puzzles. I rather would spend the time on Nano. So yeah, no, I won't this year. Maybe next year. Do you? Who of you, chat? Who of you does take part in the Advent of Code puzzles? Do you, LFLF? Illibob. Or Nano. Okay. Yeah, those puzzles, they are so much fun. Yeah, says Illibob. Those puzzles are so much fun. LFLF says, I lag behind. I'm at day 4, also because of time constraints. Yeah. Like if you have a job, it's really... And maybe even a family at home and other things to do. Oh. It's hard. But yeah, maybe next year. So what was it I wanted to do? Oh yeah. So we are sorry. We are yak shaving. So we have to create an overload of get accounts that takes a transaction. So let's do that. Let's create an overload of get accounts, and that should take the transaction. And yeah, let's copy that. And let's go to this one. Let's copy that. And the transaction. Oh, is there a deadlock situation here? Hope not. Because what I did, I also had to add a lot more locking than in the C++ code. because I noticed in the C++ code that access to this items field, access to this items field is done sometimes with locks and sometimes without locks. And what I did, I added the locks everywhere because we have to lock it in Rust later. But that means we have to be careful if we lock first and then start the database transaction, or if we do it in the other way around. This looks really dangerous to me. Because in all of the code that I wrote right now, I always do the lock first and then I start the database transaction. We have to be careful with deadlocks. Okay, but let's go. Let's maybe make a note here, and let's go on. So the transaction is open, and then we have to. Yeah, I just wanted to reuse the code down here, but this would just change the way this would flip the transaction. Okay, it's a retransaction, so this doesn't matter. Retransactions don't block. But write transactions do block in LMDB, so that's where we have to be really careful. So this is maybe not a problem then. It's a retransaction. Retransactions are safe. So we can say get accounts. Transaction. Wallet ID. Okay, so we have that one. Let's go back. And now where were we? Where were we? Oh, I lost track. Was it in here? Here we are. So the wallet account impl. Yeah, so now we can use the correct transaction. So this line is now not an error anymore. And then we have to fix this if statement. So this just checks if the account is there. So if it contains the account. So here we should say if, we should say something like if find, what does find? Okay, so now we have to is there an exists? No, I think find. No, find returns an iterator, right? So here we can say accounts begin. Accounts end. So we're going to search the whole accounts vector. And we want to find account A. Does that work? I don't know C++. I have to Google a bit. Sorry. Find. Find if not. How does it work? Is there examples? Okay. Okay. So if std find is equal to is basically, so we can copy this from down here, is not equal to, no, we can't copy, is not equal to accounts end. So this is the new if statement. It searches through the account vector for account A, and if it finds something, we say true. And this is inefficient because now we have to load all of the accounts. In practice, I think there will just be one account. So in practice, maybe this is not even a problem. But let's just keep the to-do here because we want to be as efficient as the C++ code later. But temporarily replacing this with just a vector search, I have no problem with that. Okay. So are we done with this function? I think we are. So now we just have to fix all of the errors in our code. And look at that. There are plenty. Plenty of errors. Let's go through them one by one. Okay, account remove. This is also an RPC function. And we have to say wallet ID, and we also have to give the wallets a wallets instance. Okay, that fixed it. And what is this down here? Wallet store erase. So this removes an account, and I think we can do that via the wallets class. RPC. Is that a pointer? What is it? Oh, it's not a pointer. Wallets, remove account. Remove account. Oh no, we have this transaction problem again. We have to create an overload that takes a transaction again. Or do we? I think we don't, because this transaction... Oh, here it's used here, okay. Oh, do we have now? Do we have to create overloads now for all of them? Oh, okay. A welcome pause. Break. 1 nano. LF. Also very close. This is again creating the transaction first. And here we should have the transaction then. Like that. And the wallet ID, we have the wallet ID. And what is the account ID is this one, account. No, what is account? This should be an account ID. Too many arguments. Oh yeah, too many arguments, okay. Yeah, I think we have to create an overload here for the remove account function. Okay, let's do that. And this requires us to have a write transaction. Nano store, write transaction. Like that. Oh, it's called txn here. Txn. And then down here, let's just flip this around. The account ID. And now we can add this to the header file. Okay. Yeah, I don't like this, that we sometimes have this function with a transaction and sometimes without. We have to clean this up later. Okay, so do we have more errors to fix? We do, in the account representative set function. Account representative set. Wallet. So instead of the wallet, we have to say wallet ID. And we don't say wallet impl, we say get wallet ID. So this loads the wallet ID from the HTTP request. Down here in the wallet locked impl, we say RPCL node.wallets and the wallet ID. Same for the wallet account impl, which loads the account from the HTTP request. We do the same. No. Why does this take wallet, by the way? I have, yeah, for the check. Okay. So here we also say RPCL node.wallets and wallet ID. Okay. Yeah, that fixed the error. Next error down here. So this is the same function still. Change async. Yeah, so we want to call change async, but we want to call it on the wallets class. So that means we have to say, how do we access the wallets class again? With RPC_L node.wallets.change async. Oh, there is no change async. So we have to create that. And this change async should then take a wallet ID. So that's bad. Change async. So we have to go to the wallets class. And I should have done it in small steps. Now I regret that I started it as a big task. So we have to add the change async into our wallets class. So there is a change async in the wallet class. So let's copy it from here. Let's go down to the wallets class and put it, where is the async? Here, there's a receive async. There's a change sync, but not a change async. So let's add a change async here with the wallet ID. And let's go to the implementation. And let's copy the signature, the arguments one more time from the original one. This is the original one. Copy them. And let's paste them here. And now what we want to do is we want to find the wallet with by the wallet ID, and then we want to call change async on that wallet. And this takes source A, representative A, work, and generate work. What? What's the problem here? I think, oh, okay, action. I think I forgot something here. I think there is, before the work A, there's an action A. Yeah. Okay. We got that. Let's go back. Okay, so this is a lot of jumping back and forth. I shouldn't have done it. I shouldn't have done it in one big step. Because maybe this is now confusing for you, chat. Because I jump from file to file so often. LFLF says, how long did it take for the regret to set in? 30 minutes? Don't give up yet. Yeah, so this is my usual experience when I say I do something in a big step. A lot of the times I do this, I regret doing it. But I'm a bit stubborn. There. Yeah, I should have done it in smaller steps because now we can't compile. So I did it on purpose just to demonstrate how stupid it is to work in big steps. 1401 says, heads off to you if you finish the section without any unexpected errors. Yeah, maybe we won't. I'm getting less and less optimistic. Yeah. Yeah, it was a stupid idea to do this in one big step. Because now we can't compile, we can't run the tests. We are stuck. LFS says, thanks for the sacrifice then. Yeah. So yeah, so this was all on purpose, I got myself into all of this trouble on purpose. Let's go. Sergio. All right. Is the timer running again? Yeah. Okay. So change async. Let's search for the errors we have. The next error is in, what is this function? Block create again. We were in block create before. Sergio says rigged. Now it's rigged for you. Yeah, wallet locked impl doesn't take wallet anymore, but wallet transaction of wallets and wallet ID. So transaction, yeah. So this is too much. This has to go. And wallet account impl takes transaction, wallets, wallet ID, and account. So this takes transactions, wallets, and is wallet the wallet ID? Yes. Okay, that one is fixed too. What's that? The password change function. Okay, this password change function, the wallet ID from the HTTP request instead of the wallet. And then it should call wallet locked impl with wallets instance and the wallet ID. And what does it do down there? Expected closing parenthesis. Did I mess something up with the parenthesis? I don't see an error. Maybe this is a false error. All right. Yeah, so it says rekey, and I know there's a rekey function in the wallets class, so let's call that one instead. And we have the transaction problem again. We have to create an overload that takes the transaction. So we have to create an overload that takes the transaction. Like that. Like that, yeah. Okay, let's go to the rekey function. Let's create a copy and one that takes the transaction. No store. Write transaction. Okay. And down there, we just call our copied function. Like that, wallet ID and password. No? Rekey? Ah, okay, we have to add it to the header yet. So let's do that now. Let's add it to the header file. And that should fix this error. I'm drinking my kids' cough tea, anti-cough tea from my kids. Must be good for grown-ups too, I think. Okay. Yeah, so that fixed the problem. Cannot initialize a variable of type bool with. What is the return type? Oh, does rekey return a bool? Oh yeah, so we have to do that too. Does it? Yeah. Okay. Ah, we are getting there. I'm so... I wonder if this compiles and if the tests fail, pass. Wallet transaction. So here we again, we have to take the wallet ID instead of the wallet with get wallet ID. Then here we have to pass. Do we have the node here? Node. Yeah, wallets and the wallet ID. Here we have to also say node.wallets and the wallet ID. Okay. And here we have the next error. So this loads the representative. So let's copy that and let's rewrite it by using node.wallets.get representative with the transaction as an argument and the wallet ID. Okay, that was easy. That was easy. Next error is this one. Wallet receive async. So here we have to say node.wallets.receive async. Oh, there is no receive async. Pogoman, hey, how are you? Do you know how to code in TypeScript? Oh, no, I don't. I don't know how to code in TypeScript. I work with Rust and a little bit of C++ here and C#. These are my three main languages. Oh, you're from Twitch? Welcome. That's cool. We work on the nano cryptocurrency. If you want to win nano, you could just post your nano address and we give away one nano every 10 minutes to one lucky winner. So wallets receive. Where was I? Yeah, so we have to say async, receive async, but there is no receive async. So let's do that first. Let's go to our wallets class and let's add a receive async. So this is the receive async from the wallet class. Let's go down to the wallets class and let's add it here. Oh no, there is a receive async. No, it's receive sync. We need a receive async. Okay. The receive async should take the wallet ID. So 1 nano goes to butterfly. So butterfly is getting 1 nano. And there you go. So receive async. Congrats, butterfly. Yeah. Receive async. We have to implement that. And a wallets. And again, I have to copy the parameters again from the original receive async. This is the original receive async, so let's copy the parameters and put them here. And let's write the implementation. And it should do the same as these functions up here. It should find the wallet by the wallet ID, and then it should call receive async. And what does that take? Hash representative amount count Action, work, and that's it. And generate work. Yeah. Okay, let's go back to where our arrow was. No. Here. Yeah, so now we should be able to call the new, yeah, here it is, receive async. And it should take the wallet ID and all of the other arguments from down there. Yeah, think that's good. Tedious work. I hope this works out well. What is this? This is the function send. The send function. And again. So this is like very repetitive now. I wish there was a way to automate that. Maybe if I would show ChatGPT what I would do, and I would say like repeat this for all of the other errors. That would be cool. Get wallet ID. So we get the wallet ID. And then down there we say node.wallets. Node wallets and wallet ID. Wallet account impl also should take node.wallets and wallet ID. And down there we have send async. So here we also have to say node.wallets.send async. Oh, we have a send async already. That's good. So it takes the wallet ID and then it takes all of the other arguments. Do you see that, chat? Our error list is getting smaller and smaller. Just 4. Maybe we can even start a compile cycle. So that is the function sign. The sign function. Let's go to the top. Now where's the wallet coming from? Where is the wallet coming from? Oh, here. Yeah, so this should just call get wallet ID. Wallet should be called wallet ID. And here we just say node.wallets. Node.wallets and wallet ID. Same here, node.wallets and wallet ID. And what is this line? It loads. It loads. What does it load? The private key? Store.fetch. What does this load? Does it load the private key for this account? I think we can do that with node.wallets. I'm not so sure. Let's have a look at who calls this fetch function. Who calls this fetch function? No one. Really. So the closest is maybe this here. What is this? Decrypt. Huh. What does decrypt do? Decrypt returns all private and public keys from the wallet. Is this the same thing? Is this what we need here? This loads a private key. But just one. Okay, we have to add a fetch function. Like that. We have to add a fetch function like that. So let's do that. Let's go to here. Let's copy this fetch function. Let's go down to wallets class. And let's, whoa, where do we put that? Maybe close to the function that loaded all private keys. Here, the decrypt function. Yeah, let's put it here. And this should take the wallet ID. Like that. So let's implement it. And then we just call the original function. Yeah, what is this? So this is the key and the account. This is the transaction. So here we just say existing second, which is the wallet, dot store dot fetch, and then we say that give it the transaction, the account, and the result will be written into this key. Yeah. Yeah. Okay. Only 2 errors left. Oh, I'm getting excited. In this file, I have to say, only 2 errors in this file. Maybe there are more errors in other files. Who knows? Work get is the function, so this should also just take the wallet ID from the request. Get wallet ID and give away. LFLF, another nano for you. There you go. LFLF says, still great progress. The other files will come next. And then I just have to fix old errors faster than I introduce new errors. Okay, wallet ID. Yeah, so wallet does not... Yeah, so here we have to say wallets and wallet ID. Sometimes programming is really boring because we have to make the same change over and over again. Okay, here we are loading the work. I think maybe this is the pre-generated work. Can we get the work? with over the wallets class. Yeah, there's a work get. Work get. Work get takes the wallet ID and an account. And account is account. And this returns the work. Oh, here's the work. Okay. Yeah. Last error. Chat, last error. Last error. So what is this? This is work set. Okay. Wallet ID. We have to say get wallet ID. And RPCL node wallets and wallet ID. And here we have to say work put. So work put, we have to call a work put on our wallets class. So RPCL node.wallets.work. There is no work put. There is no work put. That's bad. So we have to add a work put function to our wallets class. So let's go to our wallets class. Let's search for the old work put. And let's copy that. And let's go to our work. No, work get. Here. This is our wallets class. Here we say work put. We have to give a wallet ID. And let's implement that. And what are the arguments? Wallet ID, transaction, what is public key, account, and this is the work. And what we do here is the same. We lock, we find the wallet, and then we say wallet. That was a store function, right? Store. Work put, transaction, count, work. Yeah. Okay, let's go back. No more errors. Okay. Let's see what happens if we start to compile this. Yeah. Let's compile this. And let's run the tests. Okay. That was a huge chunk of work. I should have done it in small steps now. Yeah, I should never work in huge steps, really. 1401 says, Gustav in next dev space, so I have integrated the whole node software into one single function. Yeah, so that fixes our dependency issues. That is a good idea. Yes. So, but while this thing compiles, let's just have a look at yeah, the diagram from the beginning again. So, so what we did today, let's recap a bit. Yeah, we worked on the node so that the node would only access the wallets class, and it would not access the wallet class, and it would not access the wallet store. And that turned out to be quite a bit of work. And I did the same for the tests last week, as I said earlier. And I think we are now in a good place so that we can merge the code or move the code from wallet into wallets back into wallets, so that we have a huge chunk of code, like a huge big ball of mud, and then we can split it up again in a better way. LFLF says, still hope we don't have to see this ugly CPP code much longer. Yeah, we will, I'm afraid. But look at that, it still compiles. It still compiles. And yeah, so and now we have some time because compilation takes a couple more minutes maybe. Let's go back to coupling and cohesion. I listened to a talk from Kent Beck today where he talked about it, and this was so interesting because coupling and cohesion, those two terms, they are so important in our job. And Kent Beck said, like, coupling, his definition of coupling was if one part changes and you have to change the other part too, then those are coupled. And cohesion, he said, means that all parts within, like our internal parts, that they are coupled. So if I change one internal part, that means I have to change the other internal parts too. For example, a field name in a class. If I rename the field name, if I rename a field in a class, I probably have to change the methods that use this field. So that's cohesion. Cohesion is internal coupling, and cohesion is good. So this is what we want. We want cohesion. We want internal coupling, and we do not want external coupling or a lot of external coupling. So what is the... Oh no, the compiler failed. Compilation failed. Wallet.cpp. There is something wrong in wallet.cpp. What is wrong in wallet.cpp? Oh, there's a return missing. Anything else? No. Let's retry. Let's retry. Yeah, so I think coupling and cohesion, that's, for me, that's one of the most interesting topics, really. Because that is also very difficult to get right. And if you get it right, you have a system that is just very easy to change and to understand. Edie Bob, 1 nano for you. 1 nano for you, Edie Bob. There you go. And yeah, we just have 1 more nano to give away, is that right? Yeah, so I won't restart the Bitcoin block timer because we are almost at the end of the stream. And let's keep an eye on the compiler so that he's still building. Yeah, so coupling and cohesion, that is so interesting, and it's so difficult to get right. And that's also where I see a lot of potential in the Nano node for improvement. Because there's a lot of unnecessary coupling. And that means unnecessary coupling means that when we change code, we often have to change the coupled parts too, and that slows us down. So that's why we don't want to have a lot of coupling, because coupling slows us down when we work with the code. And that's my goal. That's my goal. One of my goals with RsNano is to improve the coupling situation. So is to remove coupling and increase cohesion. I want to remove coupling and I want to increase cohesion. And one good example where I did that recently is maybe the message classes. So let's go to message.rs. No, is it message? Message.rs. and or the message header. I want to have a look at the message header. Message header. So these are messages that are sent over the network, and a message header. No, sorry, the message. Let's take the message serializer. Yeah, so the message serializer creates the bytes, or takes the messages, creates the bytes that go to the network, and it creates a message header. Where does it do that? Here's the message. Here, it creates a message header for the message, and the message header contains information about the nano protocol. Here. And this is a new struct I introduced. Protocol info, version using, version max, version min, and the network. And these three fields are part of the message header. And yeah, they just say which version of the nano network does our node understand, basically. And in the C++ code base, this information does not come from a class called protocol info, but this information comes from a class called network constants or something like that. And I don't even have the original code anymore. Let's go to the official. Let's go to the official Nano GitHub. And let's search for network constants. So this is the original Nano code. And this is the class network constants. And as you can see, it has a lot of fields, a lot of configuration. And down there are these protocol version min. So in there are these few fields that we actually need. And I extracted them out of this network constants, and I introduced this small struct protocol info just to reduce coupling, because our messages, they are not interested at all in all of these other values here, the network constants. There's so much stuff in here. There's here RPC port, IPC port, timeouts for whatever, and so there's so much stuff in here that I did not want to have a dependency on this huge class. So I extracted the protocol info, a very, very simple class, and our messages only reference the protocol info, and by that I reduced coupling. So now, whenever we want to create a message, I don't have to create this huge thing. So that simplifies development, and that also enabled me to extract the message crate that Gravity and I used last week. That was possible because the coupling was reduced. LFLF says, why are changes like these not upstream to the original CPP code base? Would make refactoring easier, it seems. Yeah, I agree, it would. So I think upstreaming those changes would make working with the C++ code base a lot easier. But I'm not doing it. I'm not doing it because I make a lot of changes. Like every day, I change the code every day. And if I had to upstream all of those changes, I would be busy all day creating pull requests for the original code base, and I would not make any progress with the Rust code base. So yeah, it would be good if those changes would be upstreamed, I think. But that is just like creating code reviews, upstreaming those changes. Boy, that's a lot of work. Like, yeah. And my focus is the Rust code base. So I'm happy to tell everyone what I do. And if there are other people who would like to upstream those changes to the C++ code base, that would be fine. But I just don't have the time. So what's going on here? The compilation finished, tests are running, and we have heap use after free. This is the issues I still haven't found. This has nothing to do with our refactoring. But it seems to be stuck. This is new. So I think I might have introduced a deadlock. LF says, totally get your point, and I'm happy you focus on Rust instead. Yeah. Yeah, so... yeah, I don't want to get distracted too much. And yeah, just Rust is my main focus. Ooh, I think I introduced... yeah, look at that. Wallet, I introduced deadlocks. Let's just run the wallet tests. Let's just run the wallet tests. And then I have to find a workaround for the deadlocks. Password raise. Let's create a branch. I don't want to merge this into the main branch. Because I probably introduced bugs now. So I want to switch to a new branch. How do I call this one? I call this use wallets instead of wallet. And then I push all of my changes to that branch. Like that. Okay. Okay, password raise. I think we have a deadlock there. And I'm pretty sure it's with the right transactions. I flipped the order of acquiring the right transactions. In the old version, I acquired the mutex lock first, and then I got acquired the right transaction, and now it's flipped. And I'm pretty sure this was the reason why it is in a deadlock situation now. Thank God we have the tests. Really happy about that. So, okay, but this finding deadlocks is annoying. I'm going to do this off stream. Let's give away the last nano. And for you again, LF. Congratulations. Okay, chat. That's it for today. We made a huge change and it doesn't work. So, yeah, I will have to figure out a way to not get these deadlocks. And yeah, I'm going to do this off stream. I've had a lot of luck this evening. Yeah, it's true. Thanks for watching. Please subscribe my YouTube channel if you are from YouTube. Give this video a like. I don't know what we will do next week. LFLF says, was fun to watch a bigger refactor like this. Hope you get well soon. Yeah. So next, my plan is to be fully healthy again next week, and then let's see what we do next week. So not so sure. Maybe we can continue our work on the wallets class, or you can also write me. You can join our Discord and write me what you want to see on the stream. Butterfly, yeah, have a good night, everyone. Have a good night. I'm also going to get some sleep. And see you next week. Same place, same time. Nano fam. It was fun. See you next week.